Morning. My name is Naavind Balan. My matric number is 2112911019. So my program is RY31. So I would like to present about my lab for transform bias the differential protection module. So first of all, so the objective that I need to be achieved, and then the is the protections for the internal and external and the bias. So for the thing, these are the procedures already instead all the existing. Then the based on the parameters, the table one determine the full load current, HV and lower side. Uh, for the transformer shows in the calculation, so I already use the formula for the S equals to 3, so 3 IV. So I will calculate the value of current for the high load. High voltage is equals to S equals to so 3 over V. So these are the formulas. I get the values. So same goes here for the I is 1 I1 over CT ratio 1. So I will get the I1 as. So these are the values. Okay, so for the circuit, so the open lab 4, and then the transformer is in a normal condition. So the switching time for the fault breakers was set to the 1000. So now I will shows that uh, circuit. So now uh, the fault will be 1000. So for the 1000, I will run it. So there will be no shipping over here. It shows that 0. So for the MATLAB, it will be here is no. They don't have any error detects from the graph. So then well, so for this part they have no any trip conditions. So under this circumcision, when the transformer operates the internal without any malfunctions or internal issues, the difference current should ideally be negligible, and current to on the primary and secondary side should be in equilibrium. To protect relay should not activate in these specific conditions. Okay, as already explained below. Okay, so for the second part, so now the I need to set the switching time of the fault block is 0.1 as shown in figure. So this one will be over the CB lower side, lower voltage. So for here will be set as 0.1. Then start to run because CT lower and CB lower. It's the middle as in figure shows. Okay, need to be set as 0.1. So here uh, it will be so let's detect that 0, so no any fault over there. Okay, I will run the simulation. Then for this part, the external I have reconnected over here for the external. So it will be uh, as graph as shown in this. So it will detect error. So but it is below that I. So this suggests that the equipment has been analyzed or the area being protected is not present at the locations where the issue is happening. The external fault is an issue that impacts system components located beyond the protective zone, such as transmission line or other interconnected equipments. Once the model is run, so there will be no trip, so the protected equipment remains linked and not separate due to the absence of the trip initiated by the protected relay. the likely cause or the outcome is to present the external fault type. The relay may not immediately activate a response to the internal fault occurring beyond the protected zone, depending on the specific structure and configuration of the protection system. So for the 9, set the fault block connection in the figure 4S. Uh, before the transformer 132 over 11 kV. So maintain the switching time is 0.1. So for here, I will show that sheet will be over here. So once I will run the system, it will show that the tripping over here equals to 1. Okay. So here I will set as 0.1. I will run the circuit. So once I run the circuit, mm, it shows 1. That means got tripped. So over here, once I run the circuit, so it will have the IR is more than the ID. So there will be trip. So in this situation, in the scenario, the relay is configured to quickly detect the fault failure and initiated process to isolate the affected region and connected of the fault block at a main transformer indicates that the fault occur either on a primary side of the protected equipments or inside the transformer itself. The protected system must be promptly response to prevent the any harm to the transformer and other related equipments in the events of the internal occurring inside the protected area. So once I run the uh, relay characteristics, then I will get the value of this. Then I will print screen and then paste here. So from here, that's all from me. Thank you.